Okay, so very good morning, students. In last video, we started a topic that is the force exerted by jet on the stationary curved plate. Okay, and as I said, there are the two cases. The first case was jet strikes the curved plate at the center. Means what? The curved plate was just in front of the nozzle. Okay, means what? The jet was striking the curved plate normally. You can say it is striking normally. And the second case is the jet will be striking in the plate tangentially. So in this video we'll be going through the next derivation. So in this derivation the uh, jet will be striking the plate along the tangential direction. So as I have written here, the jet strikes the curved plate at one end tangentially when the plate is symmetrical. So for that purpose this is the diagrammatic representation where you can see that there is a pipe, correct? This is the pipe and there is a nozzle connected, correct? And this is the curved plate, okay? And this is the jet, correct? Over the surface, and the jet is striking the plate tangentially, means what? From the bottom end and not from the center. So the formula will automatically change, whole derivation will change, velocities and the components will be changing, correct? So we will be going to the derivation. So before going to the derivation, you should know that the jet strikes the curved plate at one end tangentially as shown in the figure, and one more thing, that the curved plate is symmetrical about the x-axis. Means what? Suppose this is the x-axis, then it is symmetrical along the x-axis, and the angle made by the tangents at both the ends will be same. Means what? Suppose this is the v, this is the arrow, and this is the angle made with the horizontal, then this theta and this theta is same. Means what? This is the angle at the entering point. So if it means what? Suppose the jet is entering from this end, correct, at this angle with respect to horizontal, and suppose we are writing this as a theta, then at the outlet point at same angle the water will be leaving with the horizontal, correct? So the theta is same. Okay, so for that purpose we can rotate as the next point that v will be the velocity of the jet at uh, at the entering point or at the leaving point, correct? Since v is not at the since v is not in the x or y axis, so we will be making a component, correct, in x direction and in y direction. So at this point we will be making two components as we have written theta with respect to horizontal. So obviously the horizontal component will be v cos theta and vertical component will be v sin theta, correct? So these are the component at entering point. Similarly at leaving point, the water is leaving at a velocity of v, correct, but at an angle of theta. So obviously we will be making and two components along in x and y direction, correct? So the horizontal component will be v cos theta, correct, because the angle is here, and the opposite will be v sin theta. Okay, so as you can see here, v is the velocity of a jet of water and theta is the angle made by the jet with x-axis at inlet tip of the curved plate. Okay, so if the plate is smooth, and loss of energy due to impact is zero, then the velocity of water at the outlet tip of the curved plate will be equals to v. Means what? We are assuming one thing, that the loss of energy along the surface will be equals to zero. So the velocity through which the jet is entering the curved surface will be same as the velocity leaving from the outer end or the upper end, correct? So the velocity will be remaining same. There will be no changing in the velocity or decreasing in the velocity, since the loss of energy we are not considering, correct? And the next point is the force exerted by the jet of water in the direction of x and y will be, so the first will be Fx. Fx means was the force exerted by the jet in the x direction will be equal to, again we will be writing the same point. So the first point will be the Fx equal to rate of change of momentum in x direction, correct? So next second point will be it is equals to initial momentum minus final momentum divided by time, correct? So after that we will be writing as initial momentum equals to mass into initial velocity minus final momentum will be equal to mass into final velocity divided by time, okay? So in the bracket mass is a common, so we will be taking out of the bracket, so it will be mass divided by time into bracket initial velocity minus final velocity. So we can write it as a, so after that the next step will be this mass per second into initial velocity minus final velocity. So I am just avoiding the upper steps, so that steps are common for all the derivations, so I am just skipping that steps. If you want you can write that, if you want to skip then skip for just practice purpose, okay? So as we know that mass per second will be given as rho into q, as we have done in the previous derivation. So v1x means what? Velocity at starting point in x direction. So suppose this is the first point, correct? This is the second. So at first point v1x means was vx means the velocity in x direction, it is v cos theta, correct? So we can write it as v1x equal to v cos theta, correct? And v sin theta is v1y equal to v sin theta. And second point it will be v2x will be equals to minus v cos theta, correct? Why minus? Because it is going to the left hand side. So for that purpose we are using this sign convention, left side minus downward minus upward positive, right side positive, standard sign convention, okay? And the next v2y equal to plus v sin theta, correct? So these are the velocity components. These two components are on the first point and these two components are on the second point, correct? And these components are on the entering point and these two are from the leaving point. So as per the equation states that mass per second into initial velocity in x direction minus final velocity x direction. So mass per second will be writing as rho into q into bracket initial velocity is v cos theta, correct? v1x, and v2x means it will be minus v cos theta. So minus of minus, this minus is of the formula and second minus is from the component, correct? So it will be rho into a into v. This q has been written as a into v, correct? So in bracket it will be v cos theta, minus of minus it will be plus v cos theta. So it will be rho into a into a little bit, so v is common here, so I can take out of the bracket, so it will be v square into bracket cos theta plus cos theta, it will be 2 cos theta, correct? So the final equation is 2 times of rho a v square into cos theta. So this is the final equation of force exerted by the jet in the tangential direction, correct, in x direction, correct? Similarly we will be doing for Fy. So Fy is equal to, again the common step will be first step equals to rate of change of momentum with respect to time. So second step will be equals to initial momentum minus final momentum divided by time. So initial momentum will be equals to, we will be writing as mass into initial velocity minus mass into final velocity divided by time. Correct? So next step will be, we will taking mass as a common from the bracket, and it will be initial velocity minus final velocity divided by time. Okay. So again the next step will be mass per second into bracket initial velocity minus final velocity. Correct? So we know that mass per second will be equal to rho into q. So q will be replacing by a into v. Correct? And in bracket it will be initial velocity minus final velocity. So v1y minus v2y. So rho into a into v, v1y. v1y means it's v sin theta, and minus v2y. v2y is v sin theta. Both are having plus sign. So it will be equals to rho into a into v sin theta minus sign from the formula v sin theta. v sin theta minus v sin theta will be equals to 0. Correct? So you can clearly say that the force exerted by the jet in the y direction when the water is acting tangentially is equals to 0. Means what? There is no forces acting along the y direction when the jet is tangential. Correct? So we can say that this is the final equation when the forces exerted by the jet in x direction, and this is the forces exerted by the jet in y direction. So here we complete our derivation from the curved surface. So if anyone have doubt regarding any formula or any concept, can message me or call me. I will try to solve it more easily. So thank you so much for watching the video. Thank you so much.